In this lesson video, we'll be looking at Physics 1505. We are still busy with Newton's second law. This is a practice question whereby we'll be looking at one of the questions. Let us start. We still continue with examination preparation, and we are still yet busy with the basics of this chapter. So let us look at how we go about answering these questions for this particular question. The question says a man is pulling a 30 kg box to the left along a rough horizontal plane with an inextensible rope that makes an angle of 45 degrees above the horizontal. He applies a force of 250 newtons and the coefficient of kinetic friction between the box and the surface is 0.6. Now, I normally say before we can answer any question, if we are given a scenario like this without a picture form of this scenario, the first thing we do, we just simply draw the scenario or translate the scenario, interpret it, and make a picture form of the scenario. So this is a box which is 30 kg, and then it is pulled along a rough horizontal plane. So this plane is actually rough, and then it's pulled this direction, and then the force, it makes an angle of 45 degrees, and then the magnitude of the force is 250 newtons, and then we're given that the coefficient of between the box and the surface is 0.6. So basically this tells us that we do have kinetic friction experienced by this object. So this is a picture form of what is happening here. And you should also take note that in physics we do have keywords. We do have indications that we should take note of that will assist us when it comes to choosing equations or when it comes to answering the questions. Now let us go to the first question. It says draw a fully labeled force diagram for the box. Now I will further extend this question and say also a free body diagram. Now talking about a force diagram, since we have the coefficient, we have kinetic friction moving this direction, and then we have our weight, which is Fg, and then we have our normal force since it's on top of a surface. Remember that when it's on top of a surface, there is normal force. It's a force that is exerted by the surface onto the object. So this is our force applied. So you can say this is our force diagram. Then looking at a free body diagram, we are going to put a dot, and then we have our kinetic friction in this direction. We have Fg, we have normal force, and then we have our force applied here. So as you can see, it's 4 marks. This 4 marks simply guides us on how many forces are acting on the object. So as you can see, the free body diagram and the force diagram, we have 4 forces. Now let us go to the second question. It says calculate the kinetic frictional force acting on the object. Now kinetic frictional force is the force experienced by the moving object relative to its surface, and it is opposite to the motion of the moving object. Since the object is moving this direction, kinetic friction is moving this direction. So if the object changes direction and moves to the right, it means kinetic friction will also change the direction and move to the left. So now we are looking at the magnitude. Since we know the direction is to the right, let us find the magnitude. Now whenever you see a coefficient within a scenario, you must think about this equation. Normal force. And then for this normal force, we have different equation for each and every scenario. Let's quickly go through them. We have the first scenario whereby an object is simply on a flat surface, and then we have an object on an incline, and then lastly we have an object on a flat surface but it experiences a force at a certain angle. Now the normal force in this situation, since you know that Fg it's equals to mg, normal force will be equals to the magnitude of Fg but in opposite direction. So normal force will actually take the very same equation, which is mg. So normal force in this equation is mg. Then looking at the second scenario whereby we have an incline, Fg is this direction, and then normal force is this direction. But you can see that normal force and Fg, they are not opposite, unlike on the first scenario whereby you can see that it's simply up and down, they form 180 degrees, there's two forces. But in this case we don't have any 180 degrees, so we cannot say normal force is equal to Fg in this case. But you should know that Fg still remains as mg. Now we have to look for the force that is actually forming 180 degrees with our normal force. That force has to be the component of Fg. The second component of Fg is this direction, which is Fg parallel, and then this one is Fg perpendicular. Now in order to find the equation of normal force, we need to find the equation of Fg perpendicular. Then you should know that Fg perpendicular it's equals to mg cos theta. Basically we can say Fg perpendicular is equals to Fg, since it's the component of Fg, cos theta. Now the expanded, when we expand this Fg, we are going to have this. So in this case it simply means that normal force is equals to mg cos theta. So should it happen that you want to calculate normal force, talking about an inclined scenario, just know that normal force is equals to mg cos theta. Looking at the last one we have our force applied at a certain angle, and then we know that the components it's fx, and then we have fy. In this case, in order for us to calculate or determine the equation of normal force, just know that you are going to take the sum of forces going up equals to the sum of forces going down. Or we can explain it further to say this equation, originally it comes from this. But you should know that we are talking about the up and down motion. So we know that when this force is applied this direction, this object will definitely move this direction. It will not move up and down. So the up and down, there's no acceleration. The object is not accelerating up or down, meaning that our acceleration will be equals to 0. Then 0 multiplied by this will definitely get 0 on the right hand side. Then F net is the sum of all the forces up and down. So we are going to consider up as positive, down as negative. Now going up, how many forces do we have? We have Fy, and we also have a force that is applied by the surface, which is the normal force. Remember that normal force is applied by the surface onto an object upward. Then we are going to take down as negative as usual, and then our Fg is the force that is facing downwards. So we have Fy plus our normal force minus Fg, since it's pointing downwards, equals to 0. And then remember that we are looking for the equation for normal force, so we are going to transpose the 2 to the other side, and then we're going to have this equation here. Normal force is equals to Fg minus Fy. Now when we expand this, remember we said Fg is equals to mg. Then we should also know that Fy is equals to F sine theta. So normal force is equals to mg minus F sine theta. This angle is the angle between the force and the horizontal reference. It's this angle. And then this F is our force applied, and then m is the mass of the object, g is 9.8. Now let us go back to our question. So you're looking for the kinetic frictional force. Then I said that whenever you are given the coefficient, think about this equation. Fk is equals to coefficient multiplied by normal force. Now we can see that this scenario, it's actually the third scenario. So where we see n, we'll have to substitute by the equation of normal force. So we have Fk is equals to coefficient, open bracket, mg minus F sine theta. Then we can go ahead and substitute. We are given our coefficient as 0.6. And then the mass of the object, let me quickly go back. The mass of the object is 30 kg. So we have 30 multiplied by 9.8 minus our force is 250 multiplied by sine, the angle is 45 degrees. We get that our kinetic friction is 70.33 newtons. Remember that we are busy with the examination preparation, so if you don't understand this, remember the lesson video that I sent of kinetic friction and normal force. It should explain what we've been doing here in detail, to know all the equations of normal force, to know all the equations of kinetic friction. The equation of kinetic friction, it fully depends on the normal force, and the normal force depends on the situation that you will be looking at. Now, looking at our last question, it says calculate the acceleration of the box. To calculate the acceleration of the box, we are going to be using this equation. F net is equals to ma. Like I said, there are tricks, or let me say indications, that we should take note of. Now we said our free body diagram is this one. This is a free body diagram of all the forces acting on the object. All the forces acting on the object. Now I want you to listen very well. We have forces that are acting on the object, and then we have forces that are doing work to the object. Just to quickly explain this, remember that work is done on an object if the force and the displacement of the object are parallel. So the displacement, or let me say the direction of the object, but the proper way to say its displacement is this direction. This object is moving from right to left. And then we look at all the forces that are acting on the object. We have gravitational force, we have normal force, we have kinetic friction. Now, how many forces are actually parallel to the displacement? When we talk about parallel lines, we're talking about something like this, whereby the distance between them is equal and then the two lines will never meet. So you can see that normal force, it's actually perpendicular to the displacement. It forms 90 degrees with the displacement. Looking at FG, it's also perpendicular to the displacement. Now, looking at kinetic friction, we can see that it's indeed parallel to the displacement. Now, that is the first force. Now, looking at our force applied, we can see that it's not perpendicular and it's also not parallel to the displacement, because you can see that this doesn't form any 90 degrees. So it is not perpendicular. At the same time, it is not parallel. So what do we do here? Let us look at the components of this force applied. We know that the first component is Fy, and then the second component is this direction, which is Fx. Now between Fx and Fy, which one is parallel to the displacement? Is definitely Fx. So let us go ahead and try to draw a free body diagram of forces which does work to the object. The first one is kinetic friction. The second one is Fx. Then you should take note that Fx is equals to F cos theta. Now this, it actually assists us on how to solve questions. Now you're looking for acceleration, and then this, instead of saying the sum of forces which acts on the object, let us say is the sum of forces which does work to the object. And we are going to consider the direction of the system or the box as positive. Let us not use the notion of saying we take left as negative, right as positive. Instead, let us say we take the direction of the system as positive. This object is moving to the left. Then we are going to take left as positive. And then we take the opposite direction, which is right, as negative. If the object was moving to the right, we take right as positive, left as negative. If the object was moving up, we take up as positive, down as negative. If the object was moving down, we'll take down as positive, up as negative. So in this case, we are going to take left as positive, right as negative. So you can see that our Fx will be positive, and then our Fk will be negative. So Fx minus Fk will give us Ma. Then our Fx, we said it's F cos theta minus Fk, it's equals to Ma. Now our force we're given as 250 cos 45 degrees minus our Fk, we've calculated it as 70.33, equals to the mass of the object is 30. And then we have our acceleration here. Then from here we can just divide by 30 both sides. I normally avoid clicking the calculator before the final answer. So just solve and then you can go ahead and punch the calculator. We get a positive answer, which is 3.55 meters per second squared. Now, since our answer is positive, and then remember that we said we take left as positive, then it means our answer is positive, and then the direction is to the right. So basically, this is how we answer this question. You just have to know what is given and what we should do in order to answer that particular question. This is Bahula SJ, and that's it for this lesson video.